Good afternoon, and you're very welcome to the AtlanTec Festival 2022. We're back again for our 8th year, and it's a packed event, as always, with over 35 events across 5 days. And this year, we're running a hybrid event, so check out the program for those events on Wednesday. We hope to see you there in person as well. And you can follow us on AtlanTec Fest using the hashtag AtlanTec. And also on the platform, you can use the Q&A function to tell us why the topics of interest to you, to pose any particular questions, or just interact with the speaker. And today's speaker is really interesting in terms of the progression of semantics and where it's going to go. My name is Gallivan. I work in the innovation office as a commercialization executive, working to sort of bridge that gap between industry and the academic community. I'd just like to take the second to thank our sponsors, without whom we just wouldn't be here and we wouldn't be talking. Year on year, they step up and support the festival and give us the opportunity to come together and talk and share our experiences. So I'll be tracking the questions on the Q&A function. Our speaker is Ed Curry, who's the site director at NUI Galway for the SFI Insight Research Centre. So without further ado, I'll hand over to Ed for his talk, and we'll see you on the far side for the Q&A session from what I hope is going to be a really interesting conversation. Okay.
Thanks very much, Ian. I'll just share my slides now. There we go. Hopefully you can all see that now. Thanks for the introduction, Ian. So my name is Ed Curry. I am as Ian said, I'm part of Insight here at NUI Galway. And my research has kind of been in the area of distributed systems and data management over the last kind of 2 decades. And really in the last kind of 10 to 15 years, I've been working a lot looking at semantics, and particularly the technology that we're going to call data spaces. And we'll talk a little bit about that today. A lot of my work has been looking at non-traditional ways of trying to manage data. So using approximate matching and looking at best effort approaches to it. And I think you'll see why that kind of shines through what we're talking about today. Just a quick few words on Insight. So Insight is our National Centre for Data Analytics. It basically brings together all of the expertise that we have across the country within a single national centre. So we have over 450 researchers, and that's building on over 20 years of research and innovation expertise on the island of Ireland, bringing together all of them together. One of the core things that we do in Insight is that we're extensive in terms of collaborations, whether it's with our European partners, but also with our industrial partners, both large and small. And over the last decade, we've worked with a lot of partners to be able to understand the implications of technology for their organizations and for their business sectors. So we're very much about collaboration and working with industry to be able to find interesting and innovative solutions to hard problems. As you'd expect from a national centre, Insight has a wide range of expertises in the area of analytics and AI, and we look to apply those expertise, everything from computer vision to sensor technologies to data and AI ethics. We apply those in a range of different domains, so everything from augmented human, smart enterprise, communities, and in the area of sustainability. What I wanted to talk a little bit about today was the kind of semantics research that we've done at NUI Galway, looking a little bit back into the history of the work that we've done here. Originally, the semantics work here was done by a centre called DERI, the Digital Enterprise Research Institute. That started in about 2006. It was funded by Science Foundation Ireland, and over the years, it has also been funded extensively by the European Commission. And one of the key things that DERI did was to look at semantics, and DERI became part of Insight, part of our national centre about 8 years ago. What DERI looked at and where the nucleus of semantics research in Galway came from was the notion of the semantic web, working with people like Tim Berners-Lee to try to realize that vision of understanding how can we move our web today from documents to a web of information. And one of the key things that DERI was doing was actually working with the W3C to define standards in the area of RDF and Sparkle, trying to understand what are the challenges that we have at trying to share data at large scales. And this has very much been, we'll say, the life's passion of Tim Berners-Lee and a large community, the semantic web community, the linked data community, over the last 15 years. What's kind of come about from that has been some really practical technologies in the area of knowledge graphs and linked data. And knowledge graphs were something that were worked on extensively in Derry probably in the last decade or so. And we started to see those technologies being used not only in areas like the open data community, but also particular enterprises taking them up as well. So early adopters of those were people like Facebook and LinkedIn, Google with their knowledge graph. And we've seen very recently more and more adoption within our technologies that we're using, things like Neo4j, and also more recently, Amazon Web Services and their Neptune service are starting to show cloud-based knowledge graph services. In terms of the adoption of the technology, we had a lot of early interest as well. So we had early adopters for some of the technologies that we developed in Derry. They were, for example, the Obama administration were adopting technologies within their open data portal. And also the whole open data movement was something that was very much about what we were doing. Looking at things like open data portals, and the actual Irish open data portal was actually developed initially by a study that was actually run out of NUI Galway with a team that were identifying what are the best practices that needed to happen. How would you set up and develop an open data portal within Ireland? And I'm happy to say that the Irish open data portal has been consistently ranked as one of the best in Europe, and for 3 years in a row is ranked #1 in Europe. And that today has been inspired by a lot of the technologies that we developed here at NUI Galway, but also it's been driven very much by the startups that came out of NUI Galway as well, such as DairyLinks. And we've also seen adoption of those technologies with the European Data Portal as well by the European Commission. So when we look at the history that we have here, there's a lot of activity and a lot of work and a lot of history that's coming from semantics at NUI Galway, particularly around open data and knowledge graphs. Here's a Gartner hype cycle curve from 2022, 2021 that kind of sets the scene in terms of what's the current state of play in the market around the areas of AI technologies and data technologies. Interestingly, semantic search, I would see very much as kind of symbolizing the early work on the semantic web and ontologies, RDF and Sparkle. And what we've seen is that technology over the last decade and a half has come to the stage of maturity. That work would have been, we'll say, a research focus for NUI Galway about 12 years ago, so around the age of about 2010. In terms of knowledge graphs, I would say the peak of our knowledge graph work would have started around 2015, where we'd have had a lot of momentum on it there. And what you can see now within industry adoption of this, at least, is that there is significant interest in knowledge graphs. Things like Amazon creating a whole cloud-based knowledge graph web service shows the potential that's there. But that's been something that we've been working on here at NUI Galway for probably the last 7 or 8 years, 9 years. And what I want to talk to you about today is, well, where are we going from this? So we have a long history here at NUI Galway working at semantics, RDF, knowledge graphs. What do we see as the future? What do we see as the opportunities for the new technologies that we need to develop? What are the things that we're working on today that we believe will be quite significant in the next 3 to 5 years? So what I wanted to highlight here, again, using Gartner's curve, is the notion of composite AI and also the notion of physics-informed AI as well. These are two concepts that are in this example, at least using Gartner specific keywords, but what we'll talk about later on is, well, how are they actually been translated, or how are they been currently investigated within the research communities and within the work that we're doing within Insight, within the Insight Center. These are very much the technologies that Gartner are seeing as transforming AI in the next 2 to 10 year kind of time frame. So we'll explore a little bit about that. But to understand the challenges that these technologies will need to face, and to understand the kind of contemporary challenges that we have for semantics, it's important for us to kind of take a look at the big picture of what's actually happening in Europe around data and what the European Commission are doing in relation to the European data strategy. So this is a strategy that was launched about 18 months ago in 2020 by the European Commission. And the focus is very much on trying to develop a European approach to data sharing. How do we actually create an approach that will use regulation to give us trust in sharing our data, that will ensure and facilitate the flow of data between different producers and consumers within Europe? How do we ensure that we have a sovereign single market for data within Europe that actually works in conjunction with the regulation that we've developed to ensure that Europe will be the #1 data continent in the world? This is very much the vision of the Commissioner of the Internal Market, Thierry Breton, and very much highlighting the importance, the strategic importance that come with data within Europe. And this very much fits within a global context where Europe itself doesn't have any large-scale data companies. We don't have any native companies in the likes of Google or Amazon or Microsoft. And looking at that from a European context, how do we actually create those large-scale data infrastructures that allow us to be able to share this data? And this is very much the heart of the data strategy when they talk about common European data spaces. So a common European data space brings together relevant data infrastructures and governance frameworks in order to be able to facilitate the pooling and sharing of data within Europe. The idea here is that you'll have the tools and services that allow you to be able to share the data. You'll have a very clear data governance structure that's compatible with the EU legislation that has been defined, and that you'll improve the availability, quality, and interoperability of data, both within particular domains and across sectors as well. What this means is that the Commission are putting forward proposals to create these data spaces within different sectors in Europe. So, for example, within the sector of health, industrial and manufacturing, agriculture, culture, mobility, etc. The idea here is that a data space will bring together the different stakeholders within those sectors to be able to pool their resources, to be able to share their data within a clear governance framework that allows different licensing models to be used, different access rights to be allowed, and different usage rights to be implemented. The key here is that we need these large-scale data spaces to be able to enable AI-driven innovation, because if we don't have high-quality data to be able to drive our AI techniques, we're going to fall behind in terms of global competition and competitiveness. So it's very much a push by the European Commission to be able to do this. To give a kind of a concrete example of what this is, just last month, the Commission actually released a communication that talked about the European health data space. So here we have a health data space where we hope to have all the data from our different medical devices, our different medical applications, shared with data that would exist within different health registries around Europe, and also including electronic health records from the individual themselves. So by having a space where all of that information is available, and then primarily looking to ensure that we have our individuals empowered, so that individuals across the EU are able to share their data across different services, to be able to share it to different healthcare professionals, so that they can access the relevant health data that's needed to be able to improve diagnoses, treatments for patients, to be able to provide access to that pooled healthcare data to policymakers, to be able to provide that access to the health data to innovators and industrial users, and to be able to also to provide it to researchers as well. So you're looking here at a common pool, data being shared by the individual, but that individual remaining fully in control. And this is, as I say, a working document that's been created by the Commission to set out the requirements of this health data space from a technology point of view, but also from a regulatory point of view as well. So this is the challenge that we face. And it's very much, when you look at the point of view here, what we really have is a large scale data sharing challenge that we need to be able to tackle. The problem with this, and the big challenge with this, is that large-scale data sharing has been incredibly difficult for us to be able to do. And when we look at the research that we've done within Galway and in the vision of the semantic web, it was very much a research project that was trying to identify what are the challenges that we have around data integration and data sharing opportunities. And one of the things that you notice, and when you look at these challenges, is that we have what we call a long tail of data that exists. So we have a lot of data that's produced. We use that data to be able to analyze information about entities and sources. But the challenge that we have is that the more data that's produced, the more difficult it is to manage, particularly when we start looking at the technologies that we have today. The technologies that we've built around relational data management are very good for being able to support a low number of frequently used items, but it's actually very, very costly to be able to use those technologies to be able to manage that long tail of data. It becomes more and more costly, more and more difficult in terms of managing that data and dealing with the heterogeneity that exists there. This is the challenge that we face today, and this is the barrier that we have to overcome if we want to be able to implement common European data spaces. The reason for this is because the technologies that we've developed or invented in a time where the scale of data that we're dealing with today just wasn't imagined. So very much when we looked at, if I was to give this talk 20 years ago, we would have been talking about large scale data, being able to fit within relational database tables. The attributes of each of those entities would be probably tens of attributes, up to maybe hundreds of attributes. But what we've seen is that as the world has become more complex, the challenge that we have now is that we're dealing with heterogeneous data. It's complex, it's large scale, it's coming from many different sources that have very large and dynamic schemas that move around. Fundamentally, we're dealing with a challenge that the data itself is being created in a decentralized fashion as well. It's not being created by any one single individual, but rather being created by lots of different individuals together. Each of these can have multiple different perspectives, different conceptualizations of reality. There can be ambiguity, vagueness, inconsistency between them, but each of those perspectives can be valid for that person, can be valid from the perspective of their expertise of how they look at it. And this is the fundamental challenge that we have with large scale data, is that we need to understand the heterogeneity and the complexity that comes with it and try to embrace that. The other challenge that we have is around the subjectiveness of the data as well. And it's particularly when you look at healthcare data, what you can actually see is that many different doctors and many different expertise might have different interpretations or different subjective views of the data that's created. When you go to social media, again, you'll see these challenges that exist when people are creating different types of data there, or they're commenting on different types of entities or artifacts. There's lots of different opinions on the world. There's lots of different subjective views. And again, these are not necessarily right or wrong, but rather they are a type of data that we need to manage as well, and something that we're not used to dealing with before. Back in, as I say, when we invented relational technologies, we weren't looking at the notion of subjectivity that exists. But what we see today is that subjectivity is something that's increasing more and more, and it's a very interesting type of data that we need to be able to manage and to be able to work with. And we need the technologies to be able to support that. A good example of subjective attributes would be the typical way of trying to find a hotel or a restaurant when you're looking for one. Typically, people might want to look for a hotel of a reasonable price at a particular location. The notion there of reasonable, though, is very subjective to that individual. Are they a student that's traveling, or are they a business executive, or are they somebody who's retired? So the notion of a reasonable price can change there depending on the individual themselves. And this points to the subjectivity that exists in the data and the need to be able to personalize to that individual, but also the need to be able to manage different types of attributes in the data that have subjectivity in them. And an example there of the level of prevalence of subjective attributes across different domains kind of show that if you're looking at analyzing things like hotels or colleges or cars, there's actually a high level of subjective data that actually goes with that. So we need to be able to have more formal data management approaches that help us deal with this type of subjective data in a more formal way. We also have the significant challenges that the data that we're creating is moving from a very structured form to unstructured forms. And this has actually only been increased by the notion of the Internet of Multimedia Things, where we're starting to see large-scale multimedia event streams being created across our society. So everything from mobility and traffic management to people creating videos, to the use of cameras to be able to support safety on construction sites, the use of drones, etc. This is creating a wealth of information in terms of rich images, of audio, and of the video that needs to be processed together at the same time. So we need to have data management approaches that will work with both the structured data that we're used to, but also these forms of unstructured data that exist out there. And this really points to the core challenge that we have within the data management community, that we have in the semantics community, is this notion of the Red Queen. So Lewis Carroll in Through the Looking Glass talked about the Red Queen. This is an analogy of the Red Queen was always running to stay in place. So always running just to be able to stay in the same place that they were. In reality, when we look at data management, I've always felt that we've never actually even managed to do what the Red Queen has done. We've actually always been falling slower and slower behind in terms of our data management approaches, because data has been the data being created is constantly increasing. The complexity of the data that we're trying to process is increasing. The computational need is increasing. The storage need is increasing. I don't feel that we've actually managed to keep up with it at all. And that's really why we need to start thinking of some radical changes to be able to try to manage the data that's been created today in terms of the different types of paradigms that we want to use. And this really is, I suppose, looking at those new challenges that we have in the area of new paradigms to be able to help us manage our data. What do we want to be able to tackle in terms of these semantic requirements? Well, as we spoke before, the challenge that we have with managing data is that it's very, very expensive. Data integration is very costly, and the technologies that we have are difficult to use and difficult to scale when we have large amounts of data. So we want to ensure that we have reduced costs for data owners, producers, and consumers. We want to ensure that it becomes easier to be able to link and create data as opposed to having to always fully integrate our data as well. And this is something that we're seeing, particularly around knowledge graphs, is the ability to be able to quickly connect and link data from different sources and to be able to associate data from different sources together by just using links. So that's another important requirement. We need to be able to support multimodal data so that we've got support for the large content space that can exist in text and images, audio and video. And we need to be able to support objective and subjective attributes and to ensure that we have human interpretability of those so that we can understand where subjectivity exists, why it exists, and to be able to manage that more formally. And then finally, we need to be able to support a range of trust, a range of accuracy that exists within these solutions. Not everything is going to have perfect results. A lot of our data will have data quality issues. It's important that our paradigms understand that and can communicate to us when they're actually using data of high quality versus data of lower quality, and to be able to make it easier for humans to be able to interpret that. So the challenge that we have is, how do we actually make it easier to be able to interact with our data? How do we make it easier to be able to work with these scales that we have? And this is a challenge that we've actually tackled before. So for some people in the room, they might recognize this image here. This is a screenshot from Yahoo, which was the internet directory back in 1995 at the start of the web. And this was basically what the internet looked like to anybody under the age or over the age of 35, I would say. If you wanted to find a particular web page on a subject, for example, Liverpool Football Club, you would actually go to Yahoo, you'd look at your directory, and you'd find the category of maybe soccer teams in England, and then Liverpool. And then you'd get a list returned to you of all the web pages that were related to Liverpool or that would be associated with it. This is a good example of a structured approach to try to organize the information that was available on the web. At the time, the web had about 100,000 websites, and it gave us exact results. If we clicked on that right directory, we would get a very high quality result. And we know it was a high quality result because it was human curated. Yahoo had people, not only were people submitting their web pages to the particular directories that they wanted them to be listed in, but Yahoo actually had people manually verifying and checking out to ensure that the web page was correctly placed in the right category. So you had very high quality results, but it's very costly due to that human curated need. Fast forward 3 years, the web had gone from 100,000 websites to 2.5 million websites, and Google was born. And this was actually a revolution in terms of how we actually approach and work with data. The notion of a structured categorization of web pages was gone, and it was replaced with this notion of a text box where we'd enter keywords and then get back search results. The key change in paradigm here was that we were no longer looking for the exact results that we were getting before, but rather we entered the keywords and Google would return a set of approximate results. And those results were computed by Google analyzing the different web pages, how they were interconnected, and analyzing the content of each of those web pages to see what keywords they'd be related to. The key thing here is that the human curated approach from Yahoo could no longer cope with the 2.5 million websites. So there needed to be a computed result to that. And the trade-off was that we actually moved to these approximate results. The results they were good, but they weren't as high quality as they were with Google or with Yahoo. And then finally, in 2012, we moved from the scenario where we had 2.5 million web pages to around 700 million websites. And the key evolution here from Google's point of view was to look at the search-based interface that they have and realize that, well, people were often entering keywords in questions into Yahoo, and what people were looking for were answers to questions and not necessarily web pages. The original paradigm with Yahoo was that, or with Google, was that you'd search for a web page and you'd have to go and look at the web page to be able to find an answer. What Google recognized with the knowledge graph is that people wanted to have those answers maybe directly as part of the interface. And that's where they started to build in these knowledge graph panes into the search results, so that when people would type in a question into Google, yes, they would get back their list of approximate results, but it also get back related snippets of the knowledge graph that Google was developing as well. And often these knowledge graph snippets could actually help them answer the questions that they were looking for. The key change here was that, again, we had our approximate results, but the inclusion of the knowledge graph actually allowed us to go back to more exact results as well, because the knowledge graph was computed, but was also curated by a crowd as well, and also curated to ensure that it had high quality results. And this is the kind of evolution that we're seeing from structured to approximate results to actually blending both together, bringing approximate results and high quality knowledge graphs within the interface. The idea is that these approaches could actually be used to help us understand the challenges that we have with data management. So here's an analysis done by Alan Halvey that kind of shows the challenges that we exist in data management in terms of two dimensions. The first dimensions here is administrative proximity. So how close or loosely coordinated are different data sources that we have. So in this example here, in the bottom left-hand corner, we have database management systems. And in a database management system, we assume that we actually do have close administrative proximity. That means that we can have a lot of assumptions in terms of guarantees around the data, around access to it, around quality, and around its consistency. At the other extreme, in the top right-hand corner here, we have web search. In a web search, we actually assume to have low levels of administrative proximity. Google does not control any of the web pages that it's indexing. They're actually controlled by third parties. So it has very, very, very loose coordination, very loose control over them, to the point where actually may have none at all. On the other dimension here, we have semantic integration. And this is the degree to which we expect schemas to be matched up, the level of integration between the types and the attributes and the names of the different data sources that we have. And again, for a database management system, we assume to have high levels of semantic integration. Whereas in a web search, we don't assume that. We don't assume that we will have high levels of integration of different web pages together, but rather each of the sources themselves are independent. So this gives us a spectrum to be able to look at large-scale data management. And the challenge that we have to do is, how do we actually reduce the cost of administrative overhead with database management systems to allow them to behave a little bit more like web search engines, so that we can use computational approaches. And that's effectively what we're looking at here. So if we go back to our previous example that we had with the long tail of data, our current approaches have high costs associated with administrative and semantic integration. But if we can actually introduce more approximate and best effort approaches, more search-based, more web search-based approaches, we can actually try to reduce that cost. So it becomes easier for us to be able to deal with larger scales of data, and also to be able to try to tackle more of that long tail of data. It's still not free, but it's definitely an interesting way to approach. And this is fundamentally the basis that we have when we start looking at data spaces and the type of paradigm that we want to create there. So a data space it's not a data integration approach. We're not trying to integrate the data in a traditional approach, but rather what we're trying to do is to have a data coexistence approach. So that the goal of a data space is to have all of your data sources there, and then to be able to provide base functionality over all of them, regardless to the level of integration that they have. The key thing here is that you're now looking at your data as something that you're going to try to search with, in the same way you'd search web pages with a search engine, as opposed to a relational database that you're just trying to query directly. So it's trying to move it more towards that search paradigm. In Galway here in Insight, we've actually had a long history of working in data spaces and developing the technologies that are needed to be able to implement them. Here are some examples of work that we've done in using linked data, data spaces and knowledge graphs to be able to create systems for actually managing smart environments. So here's some examples of managing energy, water management, and mobility that we've developed in a number of projects over the last couple of years. So the real challenge that we have is if you accept the fact that we're going to have these data spaces, and the European Commission have very much put out have kind of very much signaled that this is something that's very important from the European data strategy point of view. If you look at the notion of having this kind of best effort and approximate results as being a new way of a new paradigm for looking at how we can bring data and manage data together, well, then the key challenge that exists from a research point of view is then looking at, well, how do we use the different types of AI techniques that we have today to be able to automate the process of data annotation, data enrichment, without imposing any extra effort on data owners and data producers. And the notion here is trying to bring together the advances that we've seen in deep learning over the last decade and looking at them from a data point of view. How can we use those techniques to help us to be able to manage and work with our data? One of the key things that are important here is this notion of computational semantics. So rather than having experts sit down and define semantics within ontologies or in vocabularies, how can we use computational approaches to help us understand semantics more? And one of the kind of key trends in the area is the use of language models to be able to do that. So by analyzing large corpuses of text, we're able to build these language models that can be used for tasks such as language generation, but they can also be used for things such as numeric representation of text as well, helping us understand the relationships between different types of text. And when we look at some of the models that are there, things like GPT-3 and BERT, these are some of the innovative large language models that have been developed over the last 3 or 4 years. And they've got some very interesting results in terms of how we can use them to manage data. Looking at maybe giving it a little bit of context, what does this mean in terms of a large language model? Well, most of these are built on the idea of the distributional hypothesis. And the distributional hypothesis is quite simple. Basically, it says is that a word is kind of characterized by the company that it keeps. So take, for example, if we use the word wife, if we looked at a piece of text or if we looked at text and analyzed every sentence in which the keyword wife appears, what are the associated words? What are the words that surround it in terms of its meaning? And can we use those to be able to build what we call an interpretation vector, to understand what are the associated words that go with that word? So what we do then is we basically take our large corpora of text, and then we build a statistical model. So very much like a machine learning approach to help us understand what are the different words that co-occur within that text, and can we start trying to identify the level of relatedness that exists between those words. And then from that, we're able to build basically functions that actually help us understand what are the closely related words, what's the distance of relationship between those different words. So this gives us, we'll say, a computational based approach to understand semantics and to be able to understand the relatedness between different concepts. The benefit of this approach is that these are not models that need to be developed by humans, but rather they can be done entirely using computation. One way to kind of look at it would be as a digital twin of languages. Once we've built this interpretation vector, we're then able to use the model to be able to help us interpret semantics computationally at runtime without having to have any interventions from humans. Let's give an example of how this could work. So we have an example here of what we call schema agnostic queries. So in this example here, we want to find out who are the children of Marie Curie married to. So let's assume that we actually have our data space, and in our data space, we have 3 different sources of data related to Marie Curie, and they come in 3 different structures. And I've just represented these here as 3 different types of graphs. And what we can see is by looking through this, we're actually able to identify across those 3 different pieces of information, we could actually piece together the information that's needed to be able to answer that query. However, the challenge exists here is that there's a semantic gap between the question, the information that's been expressed, and how the data has been represented in those 3 different graph models. So what distributional semantics allow us to do is to be able to look at the query that we have here, look at the graph data that exists there, and then basically use this semantic model to be able to bridge the gap between the query and the graph data. And this allows us to be able to search for concepts and related concepts that exist in different forms and in different representations within our data space. The beauty of this is that in a traditional SQL-based system, all of the information would need to be integrated from those 3 representations, whereas this is much closer to what you'd expect from a kind of a web-based search, where rather the relatedness of the keywords are being used to identify the relevant information within the graph. So what's really interesting in the area of these large language models is that the example I've given before there is actually based on the distributional semantic hypothesis that comes from the 50s. There was significant work in the early 90s and early 2000s on small scale language models. But what we've seen over the last kind of 5 years, very much building on the deep learning trend and the large scale computational trends that come with large analysis of large complex models over large data, is this emergence of large language models. Probably the most, I think, famous one from the early 2018s was BERT, which was actually developed by Google. And then last year, 2021, we had GPT-3, which was actually was a very large media event across the world, where basically it was the largest language model that had been developed that actually was able to generate text, was able to generate different types of content that you would expect only a human to be able to create. What's interesting here is when you look at this, what we've done here is we've basically plotted these large language models, looking at them in terms of the size of parameters that we have. And GPT-3 has 175 billion parameters. And what we see here is that there's effectively a Moore's law kind of emerging in terms of these large language models, where the next model that's actually just been released earlier this year is the Megatron Turing model, which has 530 billion parameters. So we're seeing here significant increase in the development of these models, and also in the sophistication and complexity of them. What this points to is that there's significant semantic resources that we can, such as GPT-3, that we can start trying to leverage in terms of how we actually manage our data, how we actually can incorporate that into different types of services to be able to help us manage, query, and analyze data within data spaces. And the other thing to point out as well is that a lot of these models are now starting to be made available to third parties. So for example, Meta, Facebook have recently released, I think it was actually 2 weeks ago, they released their OTP model, which has 175 billion parameters. So these models, while to train them and create them does require large scale infrastructure, they are being made available to the community to be able to work with and to be able to develop services and tools. So that then brings us to basically the ideas that we talked about at the start of this. So we've seen the use of knowledge graphs, we've seen the use of large scale deep learning models. But the challenge that we have is how do we bring both of these together? So the large language models are primarily based on statistics and statistical analysis, but we need more than just statistics. We actually also need our semantics to be embedded as well. So some of those early approaches that we talked about with composite AI, Gartner talked about, well, we've been developing a lot of these approaches. We're talking here about techniques known as hybrid neurosymbolic approaches. How do we bring together neural networks which have statistical learning and reasoning with knowledge graphs which have expert curated knowledge and reasoning support? And this is very much an active research area for us within Insight, where we're looking at bringing the expertise that we have in both of these areas into solutions that allow us to be able to develop data management approaches, to be able to manage data using both of these techniques. A good example of this would be some of the work that we've done on multimodal knowledge graphs for smart environments. So, for example, within a smart environment today, you might have a building site where you would have a set of structured sensor streams that are being created. So, for example, your typical IoT deployment might have things like temperature sensors, wind sensors, the level of light that's there. You might also have microphones to identify things like sounds that are occurring on the site. And then you might also have other types of unstructured sensor streams as well. So you may have cameras that are trying to identify if people are appropriately wearing their hard hats, that they have their proper PPE equipment on, their vests, etc. So on a typical smart construction site, you're going to have a lot of different streams that are coming together. And if you process those correctly, you'll be able to try to improve the actual management and safety on the overall site itself. But this actually gives us a significant challenge, because to actually create a system like that today, What's required is that you bring together all of these different streams. You build data stream pipelines that are using lots of different classifiers, lots of different deep learning models to be able to detect and process the different types of streams that you have, whether they're audio, video, or the more structured IoT streams. And effectively, each of these systems are being created in a bespoke manner that's using deep learning techniques and also some limited processing to be able to identify patterns that might be emerging there. What we've developed is the notion of multimodal event processing, which is a formal neurosymbolic paradigm for trying to process these multimodal streams that have been created. So the idea here is, rather than having to create those bespoke pipelines, what we have is a very, very simple SQL-like query that the user is able to run to basically say, I want to be able to identify people that are not wearing hard hats, or I want to be able to identify people that are not wearing hard hats and they're using construction equipment at the same time. So by looking across all of these different streams, the system itself will actually analyze those. It'll actually use a combination of knowledge graphs and deep learning models to be able to extract that information. And then fundamentally, it'll come back with a very simple answer to the user to be able to tell them whether or not there's a possible safety violation taking place on a construction site. The idea here is that by leveraging knowledge graphs and deep learning together within a simple interface, like an SQL-like query, it becomes an awful lot easier for users to be able to analyze that rich multimodal data to be able to answer their information needs. So then finally, another very interesting area of development is known as infusing common sense knowledge within AI systems. So let's take an example of before. So again, we have a multimodal stream here that's been created of a tennis player. And by using a deep neural network, we're able to create what they call a scene graph of this. So this is, I would say, state-of-the-art approach within machine learning and computer vision, where by analyzing the image, we're able to identify that there's a woman there, that they have a racket, and that they're on a tennis court. When we talked about Gartner at the start, they talked about the notion of physics-informed AI. And what they talk about here is how do you actually incorporate background knowledge, common sense knowledge within our AI systems to be able to help improve the processing of them. So here's a classic example of the output that you can get from a deep learning computer vision model. And what we want to be able to do then is to enrich that with common sense knowledge. So the notion that a woman is capable of playing tennis, that a racket is associated with a sport that actually could be spelt in a different way, such as a racket, that a tennis court could belong to a sports club. Tennis court has a net. It's a court itself. So you can see all of this additional background information that we're able to enrich into this. So this is taken from a knowledge graph. And what we see here is that kind of neurosymbolic approach where we're able to enrich deep learning models with background knowledge that's been created by humans to give us a much richer and more accurate picture of what's happening within this multimodal data example. So with that, the conclusions that I have is that our challenges around semantics have never been more challenging. The vision of data spaces in Europe will push us in the semantics community and in the data management community to our absolute limits in terms of trying to deliver on that. There's significant challenges around scale, around the content space, around the need to handle multimodal data, the need to handle subjective data, the trust that we have in it, the cost that's associated with it. And I believe that data spaces and hybrid approaches like neurosymbolic approaches actually provide very promising and interesting avenues for us to be able to develop new paradigms for managing this data. The key thing there is that they're computationally driven, which means they're low cost. They have knowledge graphs and deep learning brought together with the new approaches, and that there's a mixture of exact and approximate best effort results that allow us to be able to explore and to be able to manage data at these scales that we haven't worked with before. And that's it all from me, Ian, and I'll pass it back to yourself.
Thank you very much, Ed. That's there's a lot there. Just remind everybody that the Q&A function is there to post questions to Ed on the presentation. Just picking up on a point that you kind of started with shared data spaces and you brought the conclusions through to shared data spaces, but it strikes me there's many stakeholders there. You can see where the payoffs will arise when it happens, But given the different stakeholders that are there, how do you see that? What do you see as the practical steps as to how that's actually going to emerge?
Yeah, it's a great question. So this is, I would suggest this is it's a societal defining moment for us here in Europe, because the Commission have identified that if we don't have these large scale infrastructures in place, Europe itself will fall behind, because we do not have those large scale data companies within Europe. So what the Commission have done is that they've actually defined within one of their programs, Digital Europe, they've actually defined a set of actions that they're going to take place there to actually bring together the stakeholders from each of those different sectors. So for each of those different data spaces, there's an activity to bring the stakeholders together to, first of all, identify what are the key technologies that we need to enable data sharing within this sector, what are the key data governance challenges that exist there, and what are the key value opportunities that exist for the sector as well. So they're recognizing that it's very much a journey that will take place, and it's not something that will be solved in 2 or 3 years, but rather it's something that we need to do over the next decade. So so I think the Commission have taken those first steps, and they're also looking at it from a technology point of view. Many of those sectors will have common challenges and common problems that they need to tackle. So they're going to try to develop some common infrastructure to be able to share across them, but recognizing that each sector will have its own challenges as well.
So, and you gave an example of the health sector, which would seem to be the most contentious one of all, given the fact that it touches upon sensitive information or personal information, and the Commission has set itself out with quite a large challenge. But do you have sight of where that challenge is being taken up, or sort of the overall challenge in itself being challenged by the data owners in terms of how they see their place, and whether they're buying into the Commission's view of how this comes together?
Yeah. So on a positive note, I think the Commission very much kind of take a human-centric kind of approach to this. They very much look at the individual and the individual maintaining control of their data. So rather than maybe say in other jurisdictions, your data often exists with the company, but rather the Commission are looking, well, actually the individual needs to own the data. The individual needs then to control how that data is used by different organizations. So they're looking at it from I would say, a different perspective than we may have today when we look at where our data exists, whether it's on different social media platforms and what else. So I think there's a lot of buy-in there in terms of it being citizen-centric. The challenge now comes is, can we actually build the infrastructure that can actually deliver on that vision? So how do we actually make it easier for people to be able to even explain or even understand the different ways in which their data can be used? So that there's a very big challenge there around getting buy-in from the individual, and also ensuring that the individual is data literate enough to understand when they're agreeing to their data being used in this way, but do they actually know what that means? Do they know the implications of that? So there's a big kind of need for awareness and for literacy around data for the average citizen, for that vision to come through. From a technical point of view, I'm pretty confident that we'll come up with those solutions. But the key thing will be educating the individual citizen in Europe about their data and the different implications of it being used.
Yeah, I mean, large challenges there, especially with regard to personal data, and it's maybe not the best place to start given the complexities involved with it. But your presentation went on to talk about the heterogeneity of the data and the search-based approach to how you're actually going to navigate those data spaces. And your presentation finished on kind of pointers towards that paradigm. Is that like a near event? Is it many years away? Is it still, where's that sitting with regard to usability or adoption, or where is that?
Yeah, it's a great question. So the interesting thing here is that if you go back to the semantic web work in the early 2000s, a lot of that, effectively, that was a research project to understand what are the challenges that we have with large scale data sharing. And I think when you look at what the Commission are trying to do now, effectively we've had 20 years of experience of trying to study and understand those systems. So there's a lot of knowledge out there about how to build these types of systems that we can leverage. The other thing is that the techniques that have been developed with deep learning over the last, as I say, 3 or 4 years, the amount of investment that's been made there actually has created a lot of techniques that we can leverage as well. So I think it's a combination of trying to bring together the experience that we have in the academic community, but also the experience in the industrial community to actually develop these solutions. So I'd be quite confident that we can put these systems in place within the next 3 to 4 years. But it will be an incremental thing after that. It's not a case of you build it once and we keep using it, but rather you build the first version and you'll keep building it, incrementally improving it as we go along.
David is a really good question here, which you're going to come to in a second. But just to finish off on that one, are there any particular centers who are taking the lead in moving this, or any particular industrial players who are more active than others in trying to bring it together?
Yeah. So from a research point of view, I would say the kind of leading institutes in Europe would be ourselves within Insight, but also Fraunhofer, VTT in Finland, and TNO in the Netherlands. So we're actively collaborating together with those institutions, and we have strategic partnerships with Fraunhofer specifically around trying to develop databases and the associated technologies and governance frameworks that go with them. From an industry point of view, if you look at the whole Gaia X movement, which has, I think, about 400 to 500 European private organizations in it, one of the key things that Gaia X is trying to achieve is, in fact, a data space as well. So we do see significant interest from industry there. Some of the key players would be SAP, would be Siemens, would be Philips, particularly in healthcare, would be Atos. So there is a significant push there and a significant pull from the industrial side, because they recognize the need for these infrastructures to be in place to drive digital transformation.
Okay, and David's question is really good. I might just read it in its full rather than trying to reinterpret it. Have there been any issues identified with prejudices in common sense knowledge enhancements?
Yeah, look, that's a fantastic question. There's a lot of work that investigates bias within data and trying to measure the different types of biases that can exist. And absolutely any common sense knowledge base or any kind of data that you use can have biases that are there. So there's a lot of work at the moment understanding how can you measure your bias and how can you understand when a data set is biased. That's there. Absolutely. It's an active area of research, and it really comes back to this notion of trust. How do you actually measure an AI system to understand what bias may exist in it and what level of trust you could have in it?
So I suppose there's two attributes, which is trust in the data, while at the same time you're trying to deal with data of variable quality and trying to bring it all together. That they're quite fundamental challenges.
They are, and to have like trustworthy AI, you need to have trustworthy data at the start. But fundamentally, like, a challenge here is that when you start looking at subjectivity and bias, lots of data, the majority of data can have some form of a bias in it. Like there's your objective data, which can be based on natural laws that occur. But once you start looking at enterprise data or any kind of data that's connected to humans, there can be a lot of biases that need to be dealt with and need to be worked with there.
Okay, so I'd just like to thank Ed. I mean, we're coming up to the top of the hour, so I'd like to thank Ed once again for his really interesting presentation. It's a signpost to, I think, some significant challenges in the future. Trust, bias, the challenges of data spaces, that they're all really good areas, and maybe in a year's time, Ed, we might have you back just to see what the trajectory has been in that time from there. But for now, I'd just like to close the session and once again thank Ed and thank all the sponsors who've made this session possible. And just remind you all that the program is ongoing. It's running for the next 5 days, Wednesdays in person. Check out the program and we might hope to see you there at some stage. So once again, Ed, just close it off by thanking you again. Okay, thank you and goodbye.
Thanks very much, Ian. Take care, everyone. Bye-bye.